Hello, my name is Johan Krause and I will present to you today our paper on metadata extraction from Cyrillic at the second workshop on scholarly document processing at the NAACL 2021. Our team consists of Igor Shapiro, Tarek Zaya, Michael Färber and myself, all of us affiliated with the Karlsruhe Institute of Technology. The paper is titled Bootstrapping Multilingual Metadata Extraction, a showcase in Cyrillic. I'd like to start by talking to you about the motivation for our work. We perceive that most labeled and qualitative datasets of scholarly documents are in English language. That means datasets for natural language processing tasks on non-English publications are somewhat limited. In consequence, automated document processing applications on these are also restricted, such as scholarly recommendation or bibliographic analysis, for example. This, on the other hand, can lead to underrepresentation of the affected publications, resulting in disadvantages in terms of discoverability and impact. That is why we chose to create a high-quality dataset of Cyrillic script scholarly documents. We then used the dataset to retrain the widespread Grobit metadata extraction tool and evaluate its utility by comparing it to a neural network that we trained additionally. We extracted two exemplary attributes from the full texts, author and title. Coming to our approach, what were the steps involved in our process? First, we select a dataset of Cyrillic script documents from the core collection of open access research papers. We undergo filtering and pre-process the set to obtain our final data. Afterwards, we retrain the Grobit tool using this dataset, since the tool presumably does not work well on Cyrillic publications. Then, we train a neural network from scratch for comparison. Concluding, the different models are evaluated in their extraction performance. Let me show you an example for the extraction and labeling process. In the publication on the left, you can see the emphasized metadata attributes that are of interest to us. We then extract the full text from the document. After that, the tools identify the relevant phrases in the text sequence. Then, the phrases are extracted and the tools return these as our desired result. So, as mentioned, we build our dataset on publications that are available in the core collection. To generate a collection in Cyrillic languages, we chose to select items with language labels of the four languages: Russian, Ukrainian, Bulgarian, and Macedonian. Next, we remove duplicates of the items that were identical in their content, even if their ID differed. Through keyword filtering, we removed publications that are non-scientific, leaving roughly 22,000 papers. The next step involved a length filtering, where we excluded all items above the 95% quantile, and a metadata check to see if the required attributes were maintained. In the last part, we removed the items for which the full text could not be extracted from the PDF file. The resulting publications span 27 years and are briefly analyzed in the following to give you an impression of the dataset. We found that roughly 3/4 of the papers were in Ukrainian language. The remaining were Russian or Bulgarian. As there were only very few occurrences of Macedonian publications in the collection, these are not included in this table. In addition, we conducted a scan through the topic attributes to gather an approximate topic distribution. You can see that the topics are relatively equally distributed and we have similar frequencies across the set. Now a few words on our pre-processing. We focused on two main attributes of a publication, the title attribute and the authors. For this, we obtained the metadata JSON files and the PDF files, from which we extracted the full texts using the tool PDF Miner. To prepare the texts for our applications, we labeled the text sequences by matching the metadata attributes to the text tokens, as you can see here below. One key question of our work was whether we could significantly improve the metadata extraction performance of existing tools through retraining on our dataset. That is why we took the Grobit model and evaluated its performance on Cyrillic script data. We then retrained it on our data to see how the performance changes and compared it to the off-the-shelf vanilla version. Regarding the neural network for comparison, we decided to go with the BI-LSTM. We prepared the word tokens using 100-dimensional fast text embeddings and added 5 additional features. We then trimmed the text to the first 1000 tokens. As output labels, we decided to distinguish between 4 categories: author token, begin of title token, inside of title, and MISC. In addition, we weighted the labels to overcome a label imbalance. We then trained using a 5-fold cross-validation with the recall metric and the Adam optimizer. Now, after training these different models, we come to the evaluation. The scores of the individual models indicate that, as you can see here, the retrained Grobit model and the neural network clearly outperform the vanilla version of Grobit. The off-the-shelf version of Grobit achieves low scores on the publications at hand. Moreover, our custom BI LSTM achieves slightly better results than the retrained Grobit instance. When observing the performance per label, one can see that the extraction of titles yields better precision, recall, and F1 scores than the author extraction. For a more detailed insight into the performance of the BI LSTM, I have displayed the different scores across the document languages. The highest values are achieved for Russian publications. This is remarkable since, as you saw earlier, the number of Ukrainian documents in the set is significantly higher. Also, performance on the Bulgarian publications is comparatively low. To sum up our paper, I would like to present 3 key contributions of our work. First, we have showcased the effective creation of a high-quality dataset of Cyrillic script documents for training and evaluation. We then analyzed this dataset comprising around 15,000 documents and made it publicly available to cover areas beyond the English publication record. And we created a sequence labeling model that outperforms available methods and demonstrates the utility of our dataset. And with that, I'd like to thank you for your attention. I look forward to your questions and comments, and feel free to explore our presented dataset and code.